So, okay, hi, good morning, everyone. Today's topic will be on the deviation of light by a prism. So, we'll be discussing how does a ray of light get deviated when it strikes a prism. So, for that, let's first consider a ray of light that is an incident ray at a certain angle. So, we'll consider an incident ray like this. This is the incident ray. Once it strikes at a certain angle, the first and foremost thing is that we need to go ahead and draw a normal. So we draw a normal over here, and then this angle is called your angle of incidence. Okay, and let's say it's represented by the letter I. And then what happens is that the moment it strikes over here, it's entering from air and it's entering a glass, because this is a prism, it's made up of glass, and this is air is coming from air. So it's coming from a rarer medium and trying to enter a denser medium. And anytime a ray of light comes and strikes any surface, and if it's trying to enter from a rarer to a denser medium, it will always bend towards the normal. So this is the normal, so it will try and come towards the normal, so it will come like this. Okay, so this is the incident ray and this is the refracted ray. Here now, again, once it strikes this, again it's striking at a certain angle. Again, what we need to do is we need to go ahead and draw a normal over here also. So we draw another normal, and then what will happen is, now this is the angle of incidence. Now this is the angle of incidence for this particular refracted ray, that is that the ray that has entered the prism. So once it strikes over here, now from the glass it's trying to come out into air. So it's trying to come out from a denser medium and it's trying to enter the rarer medium. So denser to rarer, again what will happen, it's just the opposite, rarer to denser towards the normal, whereas from a denser to rarer away from the normal. So if the normal is here, so it'll try and bend away from the normal, it'll go away from the normal. Now if you look in both the cases, okay, so what is happening is the ray of light is getting bent this way. Okay, so first is getting bent over here from this surface, so it strikes the first surface, it gets bent. Again it strikes the second surface, over here also it gets bent. So it's getting refracted at two different surfaces, that is this surface, first surface, and the second surface. Now if the ray of light, or that means if the incident ray of light did not strike the prism, means if the prism was not there, then what would happen is this ray of light would have continued to go in this direction, it would have continued this way. But because it has struck this first surface and the second surface, it has got bent, or indirectly it has got deviated, and it has got deviated at two different positions. That means it has got, so it is supposed to go straight, but it came this way, so it has got bent here. So these are the two places where it has got bent. It has got bent over here, and then again from here, okay, so it has gone this way, so it has got bent over here also. These are the two surfaces. So what I do is, you just have to check to know the exact deviation, how much it has deviated and all, and it has got deviated two surface. Over here I have this deviation, so for this one we just extend it a little bit backwards. Okay, we try and extend it a little bit backwards. So this is go over here, and then it got bent over here, so this is another position where it has got bent. Okay, so these are the two positions where the ray of light has got bent, and these are the two angles by which the ray has got deviated at the respective surfaces. So this, let's say we call it, and then please remember deviation is represented by this symbol. Okay, this is the deviation, okay, symbol for your deviation. And then, so let's say since there are two deviations taking place at two surfaces, let's call it del 1 and let's call it del 2 over here. Okay, but now we want to get the total, how much total it has deviated. We know over here, this, we don't know the exact value, but we know it's a del 1, it could be any angle. Over here also we have del 2, it could be any angle. So these are the two angles by which it has got deviated. So if I want to get the total, now just look at this one. Okay, so if you want, then you just need to know a little bit of basic. Let's say I have a triangle over here, and then if I have a triangle, if I extend this line, then let's say if this angle is x, okay, and this is y and this is z, so these x, y and z are the angles that is inside the triangle. These are called the interior angles. And let's say I have another angle outside, that is a. Okay, so we have one outside the triangle, this is called an exterior angle. We have three in there. Now there is a relationship between the exterior angle and the interior angle, not all of them, but there is a certain relation with certain angles. So exterior angle is always equals to sum of two opposite interior angles. Now what does meaning exterior angle? There is only one exterior angle, that is a, is equal to sum of, sum means it's an addition. Whose sum? there are two angles, but over here we have three, but it clearly says two opposite interior. Now what is the meaning of two opposite interior angle? Is the interior angle that is along with the exterior angle, you will not take that. The remaining two are called the opposite interior angles. So the one that is attached with the exterior angle with A is not considered as the opposite. The other two are considered as the opposite, and it's called x plus y. That's the relation. So similarly, if we have a triangle, and if it's like this, and if this is y and this is a, b, c, obviously if y will be equal to, obviously I'll not take a, it will be equal to b plus c. So that way, if you look over here, now if you look at this triangle, if you only look at this triangle, if you look at this triangle, now if I make only this particular triangle in the rough, then it looks like this. It looks like this, and this looks like del 1, this is del 2, and let's say, so these are the two. So if I say, supposing this is x, okay, so what will be x equals to? X will be equals to del 1 plus del 2. Okay, so these two together will be equal to this. So the exterior angle is equal to the sum of the two opposite interior, because I will not take this, I'll have to take the other two angle, this one. So let this angle be called del. Okay, so then what will be del equals to? Del will be equal to del 1 plus del 2, and that's what. And what is del 1 plus del 2? It's the total deviation. Why? Because this is the first angle of deviation, this is the second angle of deviation. If I add the two deviations together, then we get the total deviation. So what is the total deviation by a prism? So the total deviation by a prism is equal to this much, and it is represented by this one. And if you look carefully also, if the prism was not there, this ray of light would have gone absolutely straight, but since the prism is there, it got refracted here, and then it got refracted over here. So if you look carefully, this ray was supposed to come over here, but now it's going this way. It's going this way, means this is the deviation. So it was supposed to go straight, now it went here. So isn't this the angle of deviation? And just now we proved by the triangle also that this and this together gives me this, and this is the angle of deviation. So this angle is called your angle of deviation, and this is the deviation that a ray of light suffers when it strikes a prism at a certain angle. Okay, so all you have to remember this is that a ray of light comes, and then once it strikes, it enters a denser medium, it bends towards the bends away from the it bends towards the normal, and then again it strikes the second surface. Now it's coming out from a denser to a rarer medium, it bends away from the normal. So this is how a ray of light goes. And then if the prism was not there, the ray would have continued straight, because of which what will happen, now we need to check how much by how much it has deviated. And to check that, first we check the first surface angle of deviation is this much, second surface this much. So if I want to get the total deviation caused by a prism, then we need to add the two of them. Okay, and this together is represented by this angle. So this is the angle, okay, the total angle by which a ray of light has got deviated. We know this is fine, but where do we have to represent this in the figure? At times we'll have to show it in the figure also. Everyone knows that del 1 plus del 2, this 2, if I add, gives me the total deviation. Everyone knows this particular thing. But if I have to represent that on the figure, then where do I represent? That is what we are trying to show you over here. Okay, so that's it for the time being. Thank you very much.